It's my really great pleasure to introduce to you Professor Ann Carlson. She's the Shirley Shapiro Professor of Environmental Law, and she's the inaugural faculty director of the Emmet Institute on Climate Change and the Environment at UCLA School of Law. She's also on the faculty of the UCLA Institute of the Environment. She's one of the leading scholars in the country on climate change and policies. Two of her articles, Iterative Federalism and Climate Change and Takings on the Ground, have been selected by the Land Use and Environmental Law Review as among the top 5 environmental articles of the years in which they were published. And her work has been published in leading law journals and other journals throughout the country. She's the co-author of a leading casebook, Environmental Law, and she recently served on a National Academy of Sciences panel, America's Climate Choices, Limiting the Magnitude of Future Climate Change. And she's currently serving on an American Academy of Arts and Sciences panel studying the future of America's energy systems. She's a frequent commentator and speaker on environmental issues, and particularly on climate change, and she blogs at Legal Planet. She teaches property, environmental law, climate change law and policy, and climate and energy workshop. She was an outstanding teacher and the 2011 recipient of the university's EB Award for the Art of Teaching and the UCLA Distinguished Teaching Award, as well as the 2006 recipient of the law school's Rudder Award for Excellence in Teaching. She received her JD from Harvard, and we're very, very glad to welcome her. Please help me welcome Professor Carlson.
It's important to understand kind of just how intensely strong the scientific consensus is on climate change, despite the political divide in our country on this issue. And then I'm going to spend a little bit of time talking about the impacts of climate change, because I think it's also important to understand what it is that we're facing as we try to figure out how to solve what might be the most difficult governance problem the globe has ever faced. So let's start with a little information about the science. So this is, you may have seen this before or something like it. This is a chart of about 140 years of temperature data. The reason that we start in 1880 is because that's around the time we have really pretty good recorded temperature data. The rest of our temperature data is reconstructed from a bunch of different scientific places, including tree rings and all sorts of things. But what you can see is a trend upward, and not only a trend upward, but if you added 2015 to this graph, you'd actually see a red line that indicates an even faster increase in temperatures. I think the largest increase year to year between 2014 and 2015. And January was the hottest month ever recorded, the hottest January ever recorded in the history of temperature records. So you could still say, okay, it's all natural variation, right? That's a sort of common explanation of this, but let me just give you some background about why scientists are, with increasing certainty, quite certain that this is largely human-caused. So this is data that comes from scientific efforts to collect information about atmospheric concentrations of carbon dioxide. Again, you can see when we began. Some of this gets constructed from ice cores. We can go actually back 800,000 years. Scientists have shown that we have not seen concentrations of CO2 in the atmosphere at this level for at least 800,000 years. Why is that important? Well, it's undisputed that the greenhouse effect actually keeps the planet warm. How does it do that? It blankets the Earth with carbon gases like CO2. Those trap heat and keep the planet actually habitable. Without the greenhouse effect, we couldn't live on Earth. And we're adding CO2 principally through the burning of fossil fuels at levels that are beginning to cause real and significant increases in temperature beyond levels that maintain a kind of natural equilibrium. So the thing that actually I think is the most persuasive piece of information for me about why the science and the scientific consensus is so impressive is a process that the United Nations has adopted in which they get scientists from around the globe and some economists, some policymakers, some lawyers, not a lot of lawyers, but a few, to review on a really global basis all the scientific evidence about a bunch of important issues surrounding climate change. And they produce a report, and this group works under the auspices of an organization called the Intergovernmental Panel on Climate Change. You might recognize that name because that's the organization that, along with Al Gore, won the Nobel Peace Prize a number of years ago. And the IPCC, as it's known, puts out this report, different assessments every, say, 5 to 7 years, that are scientists' best effort to compile what we know about climate change. And here's what makes this such an impressive document. So all these scientists get together, haggle out the kind of consensus document, and then every country in the world, which is a party to the IPCC, and there are about 190 countries, that includes Saudi Arabia, it includes Russia, includes all the Middle Eastern countries, have to agree word for word on that document. And the most recent assessment, which came out in 2014, says that warming is unequivocal, and at a 95% confidence level, scientists are certain that it's anthropogenically or human caused. So that is countries that have no interest in getting us to stop burning fossil fuels, again, Saudi Arabia, Russia, and so forth, agreeing word for word with this document. When the previous assessment came out, the United States agreed to every word in the document. The president at the time was George W. Bush. This is a consensus document that really does the best job possible trying to figure out what the consensus is. And in fact, if anything, many people think it's too conservative in the assessments it makes about, for example, some of the impacts of climate change. In the previous assessment, for example, there was not very much information about how likely sea level rise, or how high sea level rise is likely to be. It turns out that increasingly there's very good evidence that we may experience sea level rise that could easily put Miami, New York City, parts of California underwater. Again, the consensus document tends to be conservative because it's trying to get everybody to agree to the language. Okay, so now let's turn to some of the impacts of climate change. And this last year, probably the most frequent impact, and so let me just back up for a minute. It's a little bit tough to connect any particular weather event to increasing temperatures. But what is fairly easy to say about a number of different kinds of weather events is that they're likely to be more frequent and they're likely to be more intense. In 2015, I think it's safe to say, was the year of two particular events that happened with some frequency. Of course, in California, it was drought. But in the rest of the world, flooding was just enormously common. And not only was it common, but these floods were record floods all over the world. So this is where I'm going to try to remember exactly where each of these floods took place, but that was on my slide. So I know that this is South Carolina. This was a 1,000-year event. Okay, flooding that is supposed to occur only every 1,000 years. We know Hurricane Sandy, for example, was a 1,000-year event, and those kinds of hurricanes are likely to actually increase in intensity and in frequency so that they'll no longer be 1,000-year events, but they'll be something like 100-year events. This, I believe, is in Maine, also record flooding last August. This is, I want to say Texas. I could be wrong, though. Record flooding. This is Texas. Texas had record floods in, I believe, August and September of this year. This is the Mississippi River rising just 2 months ago in Missouri. This is in England, record floods in December, nothing like the scene for hundreds of years. This, I believe, is in India during the Paris talks. 300 people died in these floods, exacerbated by poor infrastructure, which is actually one of the most tragic parts of the impacts of climate change. Not only are they more likely to be severe in developing countries, but many developing countries don't have the infrastructure in place to adapt to these changes in the way that the developed world may. We tend not to lose 300 or 500 people in floods. We tend to have, drainage that will help in intense flooding and so forth, even though we can suffer pretty serious damage. In countries that don't have the same kind of infrastructure, don't have the same kinds of resources, the damage is magnified by weak infrastructure, sometimes weak public health systems, emergency response, et cetera. This, I believe, is in the Philippines. Yeah, This is in the Philippines. Philippines has been, as you know, just hammered by increasing typhoons, flooding, et cetera. Again, massive numbers of people dying in these sorts of events. And again, you could say any single event, it's hard to know whether climate change is the cause, but this is exactly what both scientific models and now increasingly scientific observations are predicting. So this is all consistent with rising temperatures. Okay, then of course, California, right? We've been stuck in one of the worst droughts in recorded history. Just to remind you, those of you from the Bay Area, last January, there was no recorded rain in the month of January. We're supposed to have a lot of rain this year with El Nino. It has been more powerful, I guess, north of us. Los Angeles hasn't seen the kind of rain that we were expecting, although we may still get some more in March. But one of the things that's important to know about the drought in California, if any of you have had Glenn McDonald as a teacher or heard him speak, who's in the geography department, who studies drought, what he'll tell you is that it's not that the amount of precipitation is dramatically different from what we've come to expect in these cycles of drought, but when you combine it with higher temperatures, like now, right? How warm has it been in January and February in Los Angeles? You get water evaporating much more rapidly, and so that exacerbates an already pretty serious problem. We don't have enough water, and then more of it is going into the sky rather than being retained in groundwater basins and so forth. And California is by no means the only part of the world experiencing drought. South Africa, parts of Africa have experienced really, really exceptional drought. Parts of Russia, there's a really interesting NPR story. I don't know if any of you heard, and for those of you who are in Paris, we met with a Russian economist who was quoted in the story on NPR. Many people think, oh, well, Russia will be better off with warmer temperatures because it's so cold, and Siberia will be a nicer place if we have higher temperatures. And so this report was about how much farmers in Russia are struggling with drought. Because, of course, when temperatures increase, you can't just automatically get up and move. So he was basically on the radio saying, this is not a good thing for Russia. This is catastrophic to our agricultural economy, even though you may think that we would like to have warmer temperatures. So why do I have a picture of Syrian refugees? Well, so it turns out that the Tigris-Euphrates water basin in Syria is the most overdrawn basin. There's one other in India in the world. In 2007, there was massive drought in this area. Many people think that drought led to food shortages, economic disruption in Syria, which in turn destabilized the Assad government, which in turn, of course, led to the Arab Spring, which has in turn led to the refugee crisis. And so it's not an accident that the United States military is particularly concerned about the national security implications of a warming globe. This is not something that just affects, whether it's warm or whether there are heat waves, et cetera, but drought, water shortages, et cetera, can really exacerbate the problems that weak governments face. And when you see weak governments actually deposed, you see increases in refugee populations and so forth. And so some of the estimates about the dramatic increase we're likely to see in climate refugees over the course of the next 20, 30, 50, 70 years are really quite profound. And that has all sorts of consequences, as we're seeing, for example, in serious questions about whether the European Union is even a viable political body anymore. England voting on its participation in the European Union, that's in part a response to the refugee crisis, which may in part be caused by increasing temperatures, increased drought, the effects of climate change. This is a picture of wildfires burning in Australia. Australia this summer has had temperatures reaching 123 degrees. In fact, they've changed the temperature kind of map colors to add a new category because they didn't used to reach as high as they're getting relatively routinely these days. This is a picture of one of the Greenland ice shelves melting. Some of the long-term but really quite terrifying consequences of climate change are increasingly rapid melting of big ice sheets that in turn can cause the sea to rise. Same thing is actually occurring now in Antarctica. So it used to be sort of the standard line was that the Arctic was really experiencing the effects of global temperature increases. Now there's increasing evidence that the water underneath a number of the ice sheets in Antarctica, which holds something like 70% of the globe's water, is warming. And there are real questions about the stability of those ice sheets. that particular area of warming is likely to have a particularly strong effect on sea level rise in the northern hemisphere where we live. So these impacts are profound. They're happening all over the world. They're happening now. Back to the question of models that attempt to really calculate what's going on with the global atmosphere, which is obviously a very, very complicated thing. A lot of critiques of these models. They're very complicated, very difficult to do. But one thing to note is that a number of the models have predicted a number of effects that now seem to be occurring earlier and more intensely than the models themselves were predicting. So in many respects, what you could say is that the models are actually getting it wrong in the wrong direction. So we're seeing sea level ice, summer ice retreating much more rapidly in the Arctic than was previously predicted. We're seeing drought become much more frequent. We're seeing increasingly intense flooding, et cetera, at rates more rapid than the models predict. Okay, that's the really distressing news. So then you might ask yourself, oh, why aren't we doing something about this? And there's some kind of basic answers to that. You've probably all studied the tragedy of the commons at some point in your academic lives, right? And the problem of the commons is that group interest collides with self-interest, right? People behave in their self-interest, and that undermines what would actually be collectively better for the group. And we see this in polluting water bodies. We see it in the pollution of air. But what really makes the problem of climate change even more profoundly difficult, well, there are a number of things, but one of them is that you don't have a central government that can actually solve the problem, right? You don't have a world government. We have the United Nations that comes together and tries to voluntarily attack problems. I mean, if you think about how hard it is to get environmental legislation passed by the Congress of the United States, which does in fact have the power to do things like regulate emissions from power plants, then think about magnifying that across the 190 countries of the globe that need to collectively get together and decide how to solve the problem. There's some other problems in trying to solve the issue of climate change. Despite the fact that I just showed you a whole bunch of impacts that are occurring right now, the worst effects will affect maybe your children, my children's children, since my children are only a little bit younger than you guys. Those are when we're going to see the really serious consequences of climate change. And so we're asking people today to make sacrifices in ways that you won't actually even really experience. It's not like air pollution where we figure out how to put catalytic converters on cars and you no longer see cars, at least for the most part, belching horrible black smoke, right? And when you do, it's kind of shocking. If you turn down the amount of greenhouse gases we're emitting into the atmosphere, you wouldn't notice it. It would not change your physical experience in really any way. It's also because the emissions that we emit into the atmosphere linger, unlike air pollution that dissipates actually into the atmosphere, linger for as long as 1,000 years. So what we burn today is really accumulating with greenhouse gases that are already in the atmosphere. We already have a lot of temperature increase baked into the system that we can't do anything about unless we can figure out how to pull those gases out of the atmosphere. So that makes it an even more profoundly difficult problem to solve. And nevertheless, in Paris in December, 192 countries came together and entered into a global agreement that I'll tell you an optimistic story about, and then I'll leave you with a little pessimism too. But I think it's in some ways, I think it's miraculous because the nature of the problem that we're trying to solve, the fact that it's global, the fact that there's a long time horizon, and the fact that the biggest contributors to the problem historically are no longer the biggest contributors to the problem. And going forward, we're going to ask countries who have not yet benefited from all the economic growth that comes from the burning of fossil fuels to change their behavior when we didn't do so. It's a big political problem. So just to illustrate this just shows you where carbon dioxide emissions are coming from and where they are projected to go. Now, you can take it with a grain of salt how accurate the projections are going forward. This is meant to be a kind of business as usual scenario. Actually, the depressing thing is the business as usual scenarios that we've been projecting about carbon dioxide growth have actually been too conservative. They've been growing faster than we have predicted. But nevertheless, take this to illustrate the broader point, which is that the OECD countries, largely the developed north, are not contributing to the problem going forward in the way that countries like China and India and Brazil and Indonesia and so forth will be contributing going forward. And yet, we're asking them to stop doing what we have been doing for the past, since the Industrial Revolution, since we started burning fossil fuels in order to fuel the growth of our economy. And one of the things I think, another thing to really emphasize is that there's a lot of benefits from burning fossil fuels, right? We all drive our cars and we all power our houses and we all power businesses and take advantage of consumer goods that are produced as the result of being able to burn fossil fuels, and yet they have this long-term, very deleterious consequence. And we're now trying to figure out, can we allow the non-OECD countries to experience the same kind of economic benefits that we experienced without actually putting more carbon dioxide emissions and other greenhouse gases into the atmosphere? That's a hard conundrum. Okay, so here's a picture of the closing of the gavel when the Paris Agreement was signed. Let me go back and give you a little bit of history just to give you a sense for what Paris was about and how different it was than from what we typically do in international agreements. So let me start with the Kyoto Protocol, which was there's some history that predates that, but Kyoto was the first international agreement designed to get the global community to reduce carbon emissions and other greenhouse gas emissions. You may already know this. The United States was a very, very active participant when Bill Clinton was president in trying to get the Kyoto Accord together, very influential in the kinds of mechanisms that were included in it. And then the United States Senate passed a resolution 98-0 saying we would not ratify the Kyoto Accord. This was pre-George W. Bush. This was William Jefferson Clinton in that era. And what was the big problem? Well, what Kyoto did is that it divided the world into basically that non-OECD and OECD chart. And the developed countries had targets that they were supposed to meet. The US target was, I think, 7% reduction in emissions below 1990 levels. But there were no such limitations placed on developing countries. So China was the biggest example because that was the example that became the political kind of reason or excuse for the United States to back out of Kyoto. China had no emissions reductions placed on it for precisely the reason that I just told you. Their argument was, you've already developed. We have millions, billions of poor people. The only way that we're going to bring people out of poverty is to use fossil fuels to fuel our economic growth. India is continuing to say the same thing largely today. China has actually begun to say something different. And the United States response, at least the United States Congress response, is, okay, we have to reduce emissions. That's going to hurt us vis-a-vis China in terms of competition. So, their steel producers don't actually have to reduce carbon emissions, ours do. That isn't fair. We're not going to compete on an unequal playing field like that. China needs to do something before we're going to get serious about this. So Kyoto has a lot of benefits, and I can talk more if people are interested in what those are. Many people think Kyoto was a failure. I actually think it was a learning experience that was important and was an important precursor to what happened in Paris. But Paris basically completely shifts the way we think about traditional top-down international treaties, environmental treaties, where the treaty is set and the United Nations, the parties basically agree, we're going to impose these sorts of obligations on the parties. Paris flips that on its head and essentially allows countries to submit what are called INDCs. These are individual nationally determined contributions. And each country submitted an INDC saying, this is what we can do. This is what we're willing to do. Some of them were a joke. Russia, for example. Russia did not take this seriously. Essentially, Russia said, we're going to submit our INDC and it's going to allow us to grow our emissions through complicated reasons and for complicated accounting reasons. That's actually, they can mask that a little bit, but that's essentially what they did. But really, really importantly, prior to Paris, China and the United States, you may remember this, got together and made an announcement that each of them was making a large commitment that would be contained in their Paris submissions. The United States agreed to cut its greenhouse gas emissions 26 to 28% by 2025, pretty aggressive, not crazy aggressive, but pretty aggressive. And China agreed to bend its emissions, to stop increasing its emissions by 2030. Now that may sound like that's not a big deal, but it's actually, that means right now they need to start putting into place policies that are going to begin to bend the curve, while at the same time they're continuing to try to grow economically, right? Even though they've slowed down, their growth rates are still far higher than bending the curve would make it would be easy. And they also made big commitments to shift to renewable energy sources. That was a big deal. This was all orchestrated by the Obama administration. The guy who's the sort of central negotiator for the United States literally did airplane diplomacy going from country to country to country to country prior to the Paris negotiations to really try to set the stage for this approach. And it worked. So anybody want to venture a guess about why the United States took this pathway instead of trying to get a top-down agreement with all the countries signing on to it? Some of you law students will know the answer to this. Go ahead. Exactly, because Congress is not going to ratify a United Nations treaty that commits the United States to cutting its greenhouse gas emissions. The majority of the Republicans in Congress do not acknowledge that climate change is happening, let alone that we should begin to cut emissions. And so as a political matter, Obama knew he could not get a 2/3 vote in the Senate, which is what you need to ratify a treaty. And so this became a strategy that allowed the United States to, really push forward with a process that was going to result, for the most part, in success. There were some risks going into Paris, but for the most part, the United States had laid the groundwork for a strategy that was going to be accepted. I can't remember my next slide. Okay, I'm going to go back for 1 minute and just say, so there were a couple of other things to note about Paris that were important. So one was that these INDCs, everyone submitted them, and I think every country in the world submitted them. Again, some of them were laughable and others were quite serious. And there's actually, if you want to go on, there are websites that actually rank kind of the seriousness of the commitments that each of the countries made. But there were a couple of other things that were really importantly at stake in Paris. One was an effort that the students who went to Paris actually spent a lot of time kind of thinking about, led by a coalition of small island nations, to get the agreement to commit the globe to under 2 degrees Celsius in temperature increase, and to get close to a commitment that would keep us at 1.5 degrees Celsius. Now, that was a pretty unusual strategy, in part because we have about a degree of temperature increase already baked in. Nothing we can do about it, because remember I said that these greenhouse gas concentrations are in the air, and they're in the air for a very long, in the atmosphere for a very long time. So it was a really interesting strategic choice to push really hard on that. And I think it was symbolically really important for a lot of these small island nations who are likely to be the first climate refugees as they experience sea level rise and sometimes the entire loss of their land, to get the globe thinking about what it was doing to them with a temperature increase. Even at 2 degrees, where we're already seeing big increases, and we've had about a 7/10, 8/10 of a degree increase since the Industrial Revolution. 2 degrees could cause us a lot of harm. So that was one. Another one had to do with financing. So there's a big question about who pays for the harms of climate change. If the developed world is largely responsible for what's already in the atmosphere, should they be made to pay for the harms that the developing world is going to suffer? And interestingly, the global community by and large has said, yes, we should help you adapt, we should help you respond, but we don't want to be held legally liable. So there was a lot of debate, and if you paid any attention to this, at the very end, they were supposed to make this announcement, and it got delayed for 3 or 4 hours because one word in the agreement said should instead of what it said shall instead of should. And the United States, and it had to do with whether there was going to be this legal liability. And then a final, I guess those are the main ones. The financing, the final one was transparency and review. It was a really important part of the negotiations. The US wanted a lot of transparency. China and some other countries were a little less enthusiastic about transparency. But they did get some pretty good reporting requirements that are going to require both developed and developing nations to make reports on their progress and to come back to see in a couple of years whether the INDC contributions can actually be strengthened. Okay? So how good is this agreement? I guess that's the big question. Are we gonna get anywhere close to actually meeting the 2-degree goal, let alone the 1.5-degree goal that the agreement actually incorporates? So the answer is no, not with the current INDCs. So this is kind of a scary slide, but if you can see, so if all of the Paris pledges work perfectly, and we'll talk a little bit about how they are unlikely to work perfectly, we can start with the United States and the fact that the Clean Power Plan was stayed by the United States Supreme Court a couple of weeks ago. I'll talk a little bit more about that. But if all the pledges work perfectly, you see our emissions are actually increasing. They're not decreasing. So they're not increasing nearly as rapidly as they would if we didn't have the INDCs, and I'll show you another slide in a minute to show what I mean by that, but you can see just how rapidly we would need to cut our emissions by the end of the Paris pledge period, which is 2030, in order to stave off even 2 degrees of temperature increase. Okay, so this is a pessimistic view of Paris. I'm going to come back and tell you why I'm not so sure we should be quite as pessimistic as this. So if you want to connect this to temperature, the current INDCs get us to about 3.5 degrees of temperature increase. As I said, a lot of scientists think 2 degrees gives us a lot of problems. That's why 1.5 degrees became kind of a target in the negotiations in Paris. 3.5, we could have unbelievably catastrophic consequences around the globe, let alone the 4.5 degrees that we could experience with business as usual. Now, obviously, this is based on projections and models, et cetera. These are meant to be ranges. These are kind of the midpoint ranges as opposed to the high range. Could be worse, could be a little bit better, but the point is that under the best estimates, the INDCs do not get us near to where we need to be, okay? So why am I somewhat optimistic? Well, part of the reason I'm somewhat optimistic is that we've also had some pretty bad predictions in, I guess, a good way over things like solar PV generation capacity, which has far outpaced anything that anybody thought was possible even 6 or 8 years ago. If we continue to see these really rapid increases in generation capacity and, importantly, very rapid declines in cost, we start to begin to see a pathway to solve this conundrum we're in about whether we can let non-OECD countries grow economically while at the same time reducing their emissions. And if we can get them through technological assistance, money, et cetera, from the developed world, and by technological development within the developing countries, China is a big leader in a lot of this, then that's a pathway. So some of the INDCs are based on assumptions about continuing to use the same kind of generation capacity or modest changes in increases in renewables and so forth. And so we may see much more rapid increases in technological advances if we get battery storage for electricity. Right now you can't store electricity at scale. So you have to generate enough to meet demand, and you have to always have enough generation capacity to actually make sure that everybody can turn the lights on and so forth. If we could store it, we could go a very long way toward powering our electricity sector with renewables, when we could store the energy, store it during the peak periods of sun and wind, for example, for later use. If we then shift to an electric vehicle fleet, which is what most, not everybody, but many technologists think is the kind of wave of the future for cars, we may find it easier to cut our emissions more dramatically than what we're currently predicting, okay? So there's some bright spots. And so I do think that this process where the global community is going to get back together every couple of years and update their INDCs and try to be more ambitious gives us some hope. And there's some other really promising things. One very, very under-noticed development has been Brazil adopting jurisdiction-wide policies that have dramatically reduced the rate of deforestation. Well, forests store carbon. So if we can reduce deforestation, we go a long way toward keeping a lot of the carbon in the ground or in trees as opposed to releasing it into the atmosphere. That's a really important point of progress. If we can transport some of those policies to places like Indonesia, which have not been as successful in slowing deforestation, that can have a huge effect. And of course, in a global economy, the transfer of technology is a lot more possible. Just one little anecdote, and then I'll move to my last slide. One of the reasons that we have seen such rapid development of solar technology and such sharp declines in prices has to do with the weird combination of policies in China and Germany and maybe the United States. So China, maybe unfairly, for those of you who think about international trade issues, heavily subsidized its solar industry in a way that actually undercut US manufacturers. There were all sorts of trade disputes. But that dramatically cut the price at the same time that Germany had a policy that was actually forcing its utilities to install and move to solar generation. And the Chinese subsidies of its industry actually made the feed-in tariff program, which it's called in Germany, much more possible. So we have these weird global interactions of policies now, particularly given that lots and lots of countries are focused on trying to figure out how we actually get from here to there with much cleaner technology. I thought I had another, oh yes, here we go. Okay, so I want to talk a little bit about the US and then I'll stop. So how is the US going to get there? And I could actually talk for 3 hours about how we got here, whether we're going to meet all of this, et cetera. But I'm just going to give you a really brief outline. And the really brief outline, one thing that's important to note is almost all based on a statute passed in 1970 to regulate air pollution. And it's virtually all the result of a lawsuit that was filed that resulted in the most important environmental case ever heard by the United States Supreme Court. And that was Massachusetts versus EPA, in which the court, with Anthony Kennedy being the fifth vote on the typically split court, that's may change with a new justice on the court, said that the EPA had to evaluate whether greenhouse gases endanger the environment, and then had to, if they found that in fact greenhouse gases do so, had to issue automobile standards to cut greenhouse gas emissions from tailpipes. And through a very long and convoluted process, the federal government did so as one of the first environmental policies that Barack Obama enacted in 2009 when he became president. These are the standards. They're actually in both miles per gallon standards and in grams of carbon dioxide emitted through the tailpipe. Fuel economy is on the increase. He happened to cut this deal when we were bailing out the auto industry. The auto industry thought we were moving toward more fuel-efficient cars anyway, agreed in exchange for all sorts of loans and finances being pumped into the auto industry, agreed to these standards. And since then, they've actually been increased so that we're supposed to achieve 54.5 miles per gallon by 2025. If you are wondering whether there is going to be an effective who is president in 2017, there's a review of the 54.5 mile per gallon standard that kind of lets EPA let the auto industry off the hook. We do have some big changes. Probably the most dramatic change is the tremendous drop in oil prices, which means American consumers are less concerned about buying fuel-efficient cars than they were 3 or 4 years ago. It remains to be seen whether this 54.5 mile per gallon standard actually gets met. If the federal government doesn't do it, however, California may, and I can say more about that if people are interested. The other central part of the US commitment in Paris is the Clean Power Plan. This is a rule that cuts emissions from what are called electric generating units in the legal parlance, actually existing power plants. This is a highly technical, I think 1,800-page rule issued by the Environmental Protection Agency. For various reasons, with Antonin Scalia on the Supreme Court, it was quite legally vulnerable. 2 weeks ago, the court, in a very surprising 5-4 decision, stopped the Clean Power Plan from going into effect temporarily until lower courts could rule on its legality. A week later, Justice Scalia died. There's no question that Justice Scalia was the intellectual force behind the staying of the power plant. He routinely wrote environmental opinions, mostly, not always, but mostly against EPA. So his loss actually is not just a vote. It's also really the intellectual force behind curbing and limiting EPA authority. So it's actually a very big, it would be a very big shift on the court no matter who gets that Supreme Court seat. But one of the reasons I put these up here is because let's go back to the question of, or that slide that says, are all the Paris, if every country actually succeeds in implementing its INDCs, then we still aren't going to hit the temperature target. Well, you can see how legally vulnerable and politically vulnerable both of these are. Every Republican candidate has denounced the Clean Power Plan except for Donald Trump, and that's just because he says he'll abolish the EPA. He doesn't actually tell us that he's going to dismantle the Clean Power Plan. No one's talking about the 54.5 miles per gallon standard, but I think it's fair to say that if you're against the Clean Power Plan, probably going to come in and also undermine and loosen, if not eliminate, the 54.5 miles per gallon target set by those standards. So who becomes president actually has big consequences for whether the U.S. can meet its commitment. Who's the fifth justice on the Supreme Court, or the ninth justice on the Supreme Court also has huge consequences, because even if Scalia, the intellectual leader, is no longer on the court, a conservative may well limit EPA's authority to actually issue this plan. So I will stop there.
So one question I have is sort of the structure of how this would move forward. And you explained in Paris the United States actually took a major role in designing the Paris Agreement. If for some reason the United States is not taking a major role in these kinds of agreements or in the whole world process, is there someone else who will step in?
So the European Union has played a very powerful role historically in it's called the United Nations Framework Convention on Climate Change, so in the UNFCCC process. China played a really interesting role in Paris. So Copenhagen was the previous kind of really big climate negotiations, although they happen every year. That's one where Obama flew in and tried to save them at the last minute, and by virtually all accounts, it was kind of a disaster. At Copenhagen, China was, basically its position was, we're not doing anything. You created this problem. You need to solve the problem. Totally different role they played in Paris. I mean, one of our law school colleagues, Alex Wong, who spent 7 years working in Beijing on environmental issues, was there with us, and he said it was like night and day. China wants to be viewed as a leader on this issue. I think it sees real economic opportunities in green technology, and it's got choking air pollution. And if you decrease your emissions, your greenhouse gas emissions from power plants, for example, from the burning of coal, you also get this great co-benefit, which is you get cleaner air. So it's possible that China would play that role, but without serious U.S. at least cooperation, if not leadership, it's kind of dismal. I mean, do I think things will continue to happen? Yes, but I think we'll make far less progress than we would with somebody who's seriously committed to trying to maintain the momentum of Paris and increase the commitments going forward.
Okay, so Professor Carlson, we're going to allow you to sit down and enjoy your dinner. Thank you very much.